So I'm Jean-François M. I'm a research lead in automation for organic chemistry, and I work at the University of Liverpool. So we are currently looking on how we can apply data-driven science to chemistry to enhance innovation in the chemical space. One problem for applying any type of data-driven technique in chemistry research is the lack of data that currently exists in chemistry. And when you want to collect the data you want for machine learning or any AI, you want to do this in a very standardized way, so this data is reliable. And automation is the right medium to do so, because it first gives you the standardization that you need, but also gives you the throughput that you need to produce enough data of high quality for training any type of AI you want to use later on. So there is several aspects to our work at the moment. So we are looking at how AI applied to chemistry can allow new discovery. And we are also interested in seeing how automation can speed up work for chemists also. So like the combination of the ChemSpeed, the iSynth with the Fourier 80 is a really like good tool for collecting data quickly and with quality that is needed to train AI model. So the iSynth is our main workhorse for collecting data, creating the reaction, reformatting the reaction in NMR tube and mass spec vial, and then we use the Fourier LT and MS for characterizing the reaction and making sure that we produce either the right chemical or to give us a snapshot of what the reaction made that we can rationalize later using AI techniques. So the main impact of automation for us is data quality and also like the speed at which you can collect this data. As an example, like a normal master student or PhD student without automation will be able to do like something like 100 or 200 experiments per year. Now, in 4 months, we can collect up to 800 points without too much problem. The benchtop NMR is really the key companion to the iSynth, because you don't need to use any deuterated solvent, so that facilitates things and reduce costs considerably. Also, because the instrument is cheaper and requires less maintenance than an high-field machine, we can have one dedicated instrument just for our lab, just for our use. The benchtop is our first line of analysis once we have a new reaction. And when we have positive result from the benchtop NMR, we can take the positive reaction, the promising reaction, to a high-field machine. So it's really this idea of having several levels in terms of cost of instrument, but also in terms of quality of result. The benchtop is the first line where we can throw everything at it because it's a dedicated machine for the group. It can work 24/7, has low maintenance, doesn't need deuterated solvent. Once we have found which experiments are promising, then we can bring them to the more costly high-field machine. One of the key benefits is really to be able to standardize data collection. You are sure that from one day to the next, the volume you are going to add is going to be exactly the same one. The temperature which you heat is going to be the same one. You also have the advantage of collecting a lot of metadata while running the experiment. So you know exactly at what time something happened, you know exactly at what temperature your reaction was heated, for how long. And that really gives you the solid foundation for creating quality data moving forward. Also in terms of homogeneous chemistry, the ChemSpeed platform can really handle most of it, at least when it comes to catalysis and supramolecular chemistry. We really are happy with the capabilities we get from the machine. The Fourier 80 is here to characterize what we formed. You have one thing which is making the reaction, and then the next step, of course, is understanding what you made. And NMR has been a key technique for now many decades for homogeneous chemistry. The benchtop, the Fourier 80, is really the right tool to use with automation. As you don't need any deuterated solvent, you have very little maintenance. You have like the power of having the entire top spin suite that allows you really in terms of treatment of data, in terms of like design of experiment, really a lot of flexibility. And so you can really have the insights that you want on your reaction using this instrument. One thing that we are trying to do at the moment is really put in place strategies to produce high quality data set for chemistry that can be leveraged for data-driven discovery. The other thing that we are trying to do at the moment is extend the synthetic capabilities of our autonomous lab by integrating a new type of instrument where you can do further purification and multi-step synthesis on it, relying on the benchtop NMR at every single step to make sure that you made the right product.